All right, this is 16. So 16 is a special product. And yes, has a fraction in it, but it's still a special product, right? So we do the square of the first term, 1/4 x squared. And then the square of the last term, we ignore the negative because it's always going to go to positive. And then we double the product. So the product would be negative 7/4 x. And we double it. 2 times 7/4 becomes negative 7/2 x. And then 1/4 times 1/4 would be 1/16 x squared minus 7/2 x plus 49. So you just missed the x there. Yeah, and then this should have been squared. Valley. You're welcome. The which one? 7/2 is what you, so when you multiply them together, 1/4 times negative 7 would be negative 7/4, right? And then you have to double it. So when you multiply it by 2 or 2/1, the 2 goes into 4 twice. And it's negative 7/2. Or you get negative 14/4, but that has to reduce. Yeah.
Yeah, everything's red on. Is this good or?
So if it's red, it's just, if you're ever absent and you miss the due date on a web assign, you just go back into the assignment. It will be red. It will say pass due, but then there's a little box that says request extension. You click request extension and it sends me a message with your explanation. So I was absent. I'm asking for extension for this date, and this date should be the same amount of school days that you were out. So if you miss tomorrow, let's say, which is a Wednesday, you come back on Thursday, your extension would go till Friday. You have 1 day upon your return. If you're out 2 days, it's 2 school days. So the weekends don't count, like Monday, a Labor Day wouldn't count. So you just put the date in which it would be whatever days away from when you should get that assignment.
So does the x to the second power have to be on the numerator?
No, it's fine if you left it like this for me. Okay. Yeah. And I don't think it marked it wrong, right? Because that's the same thing. Yeah.
I got the middle part.
Okay. It wouldn't have marked it wrong had you gotten that if everything else was correct.
Oh, yeah, I got mine wrong. I got it.
So shortcut. Square the first term. Oh, no, this isn't squared yet. Square the first term. Square the last term. And then double the product. So the product would be negative 5/4. And then we multiply by 2. 2 goes into 4 twice. Negative 5/2. If you had multiplied it out, it should have been negative 10/4, which still reduces to 5/2. So when you multiply that 2, it's 2/1. You multiply the 2 times the 5, not by the 4. It's negative 5/2 x. You double the product. So you multiply these two together, and then you double it. Yep. So then this would be 1/16 x squared minus 5/2 x plus 25. All right. So we jump into factoring. So this one you're good on, right? You said you figured that one out? Hadley, okay. We jump into factoring in P4. P4 has all the different types of factoring, okay? We are going to cut the test at A, which is just the first 3 types of factoring. Hopefully this is a review from Algebra 1, especially if it was Algebra 1 honors. It's been a couple of years, and we were in COVID that year, right? So this might be more of a, oh my gosh, I'm relearning this for the first time, which is okay. But you should have learned this stuff before. We are going to talk about greatest common factor. We're going to talk about perfect square, and we're going to talk about difference of 2 squares today. So the first is something you want to do in any factoring question. You want to look at your terms, and you want to see if you can take something out. If there is a number that goes into all the terms, and if there's a variable that goes into all the terms. That's factoring out the greatest common factor. So if I look at this example, I have numerically 6 and 4. Does the same number go into both 6 and 4? Yes. What number? 2. So that part of my greatest common factor is 2. That's going to go in the front of the parentheses. And then is there the same variable on both? Yes. And we take it to the lowest exponent there. That's how we find the greatest exponent, would just be x. So then I'm putting that on the front of the parentheses, and what goes in the parentheses is the result of dividing that into each of those terms. So 2x and 2x into each of these.
Wait, why are we doing this? Isn't that simple?
So now we're working the other direction. That is simplified, but when you factor, you take it out the other way. Yep. We're factoring out the greatest common factor. So we're taking out what's common here. So 2 goes into 6 3 times, and x goes into the x to the third. This would be x squared. So my first term becomes 3x squared. The minus is there. 2 goes into 4 twice, and the x's cancel. So this is called the factored form of this. If I redistribute it, I should get my question. Yes?
When we're doing this like on the test, it's gonna say like.
It will say factor.
But then if it doesn't, then we just do what we did around last week.
Correct. How many of you have never factored before? Oh boy.
Why package on like lower scales?
Okay.
I have a question.
Yeah.
Why?
Because that's factoring. It's what the whole method is.
Just do
so it's
2x2. Bam.
What? You can't combine them. Is that what you're thinking?
Yeah.
You can't combine them. One's got an x to the third and one's got an x. So you can't combine these terms. Yeah,
So basically, it's like just doing the reverse of like.
Correct.
doing polynomial.
correct. Like this was what we would have done in section 3. Would have distributed that in. Now we're doing the reverse, which is factoring it out.
Oh.
Yep. All right, look at 1. What's the numeric thing we have in common? A 4. And you can make it -4, you can make it +4, God bless you, it doesn't matter, okay? Unless it said to make the leading coefficient positive. Other than that, I could take out a +4 or a -4. So I'm gonna take out a 4. And is there a variable that's on all 3? No, so all I can do here is take out the 4. So I'm gonna divide each term by 4, and I get -x squared plus 3x minus 4. And that's the factored form of that question. And again, I can distribute that 4 back in to check to make sure it's right, because I should get my question. Yep.
If you don't get your question.
You did
you're
something wrong. Yep. All right, go to 2. What can we take out?
3x.
A 3 and an x. Good. So I'm going to do this over 3x, and this over 3x, and this over 3x. The first one, the 3's cancel. This would be to the first, so I'd end up with x squared minus 3 goes into 6 twice. One of the x cancels, so it'd be 2x. The last one, plus 3 goes into 9 3 times, and the x cancels, so it's just plus 3. Still good? They're moving desks. Okay, 3, a little bit different. What's in common on both those terms? X minus 2, a whole binomial, okay? So I take that out and put it at the front.
Oh, so you do it by terms.
Yep.
Okay.
And I would basically be dividing this whole thing by x minus 2 and dividing this whole thing by x minus 2. So they would cancel from here and from here, leaving me with 2x plus 3. So this time what's in common was a binomial. I take the binomial out, which means it's gone from each term. Biggest mistake people make in these is taking it out twice. You're not taking it out twice. It is the common factor. So it comes out once, and what's left once that is gone is what's going to get grouped together in that second set of parentheses. This time, if I was to check it, I would have had to FOIL this out, or multiply, distribute that, and then FOIL my answer. So it's a little bit different. Yep.
Why would it cancel out with x -2?
Because you're dividing x minus 2 by x minus 2, so it would simplify and give you 1. How about 4? X plus 3. So this time this is getting divided by x plus 3, and this is getting divided by x plus 3. What happens with the first one? There's still an x plus 3. Good. On the second one, minus 4. Can I simplify that? What's 3 minus 4?
-1.
Good. So if you have that, where you can combine terms inside the parentheses, you need to. And again, if you wanted to check this one, I would have had to use the one. I don't have to use a special product, but I would use the special product on the x plus 3 squared. I would FOIL that out. I would distribute this, combine my like terms, and then compare it to this FOILed. So the check on there is not as easy. Joey. Say it, sorry. Okay, go ahead.
How did she get Oh, did we do 3 minus 4?
Yep.
Already.
No, even though you're factoring, I still gotta simplify.
Inside the parentheses, you still want to simplify. Yep.
Wait, so how would that? Oh, you would. But how would you get a?
So the x minus 3 came from the first parentheses.
Like you would just spoil that.
You mean to check it?
Yeah.
So if I was to check it, I would literally have to take this and expand it. So it'd be x plus 3 times x plus 3. And then I would distribute this, minus 4x minus 12. This is a special product, x squared plus 6x plus 9. Combine my like terms.
But how would you know to put the minus negative 4x and then negative 12?
Because you should always combine like terms.
No, I'm saying. How would you check it? Because where's negative 4x?
It's taking this. So like what if I just gave you that question and I said to simplify? You would have expanded this squared and foiled it out or used the special product. You would have distributed the negative 4 and then you would have combined your like terms.
So we're not factoring or simplifying that?
This is to check it.
Because.
We're done here for the actual question. My answer is x plus 3 and x minus 1. If you want to check it, you have to multiply it back out and compare it with the question multiplied back out. That's just to check it though.
Because when you check the other ones, you can just.
Because the other ones didn't have squareds and distributive in them. They were all already simplified. Like compare this to this, right? That top one, there's nothing to simplify. It's already foiled out. The bottom one, you have a square and a distributive. It's just to check it.
I just don't understand how you check it. Because then, what? Because are you using your answer to check it? Like, when you just.
So that was the first thing. The first thing you have to do is multiply this one out. Then you would multiply your answer out. And you should get the same thing. That's how you check it.
Oh, because the top one's not already.
Correct.
simplified? Okay. But the other ones were.
The other ones were, like, to 1 and 2 were already, there's nothing to do there in the question, right? Yeah. You would have to foil out distribute the bottom, though, like your answer. You'd have to distribute that to compare it.
And then for the third one, so
You'd have to multiply that out, simplify it, and then multiply out your answer to compare it. Yeah. All right, second type. So first type is greatest common factor. Second type is called the difference of two squares. This is usually the one people remember the most. This is one that's easy to identify what you're doing because the two squares mean that both terms have to be a perfect square. And the word difference means what? Subtraction. So these kinds, because they're going to get all mixed in together and you're going to have to identify which one is which. These kind are easy to identify if they are both perfect squares and there's a minus between them. So is x squared a perfect square? Is 4 a perfect square? Is there a minus between them? So that's the difference of two squares. That's just to identify the type. Once you see that it's a difference of two squares, then the way we factor it is square root the first term, square root the last term, and one parentheses, you're going to repeat it, one parentheses gets a plus and one gets a minus. So if I did square root of x squared, I'd get what?
X plus 2?
Good. X, and well, do this x and then do the 4. So 2 and 2, and one gets a plus and one gets a minus.
Oh.
Oh, so it's like the opposite.
So if you think about that's a special product, if we were to multiply it back out, we would do the first term squared minus the second term squared, and we'd get our answer, or we'd get our question. So it's the complete reverse of what we did yesterday with the special product of the opposites.
We only know that there's a variable. Like if you were to have 60 minus 4, you would just do that.
You would just work it out. Yeah. All right. So again, they're eventually going to get mixed in together. You want to be able to identify that those are both perfect squares and there's a minus between them. 9x squared is a perfect square. 49 is a perfect square. There's a minus between them. Okay? So what's the square root of 9x squared?
3x.
3x. What's the square root of 49?
7.
And one gets a plus and one gets a minus. These tend to be everybody's favorite.
Oh, yeah.
6. What would you get? 6x, 6x, and 7y, 7y. One gets a plus and one gets a minus. Now 7,
Same.
this one's actually tricky because what else do you notice about 4 and 100? You can actually factor out the greatest common factor from there first. So, right, because 4 goes into itself once into 100, how many times? 25. So if I take out a 4, I get x squared minus 25. And then that's the difference of two squares. It's 4, x and x, 5 and 5. One gets a plus and one gets a minus.
So you have to factor it out before you.
If you didn't catch it, you would have factored it out, right? And I would have gotten 2x plus 10 and 2x minus 10.
But can I,
And then you can take out a 2 of both of those. It would be 2 times x plus 5 times 2 times x minus 5, which is 4x plus 5, x minus 5. So same answer, but a lot more work the second way.
so which one would you recommend?
Well, either way, you get to the end. But I would look for the greatest common factor first. How about 8?
5x squared.
What do we think?
5x and squared.
What's wrong with that? Mm-mm. You just lost all the points because, what's it called? What's this type of factoring called? It's called the difference of two squares. That's a plus. You cannot factor it if it's a plus. This is prime, not factorable. Be careful. It'll try to get you.
Why is it prime?
Because there's no way for you to multiply. Like if you take your answer and you multiply it out, there's no way to get a middle term to cancel and keep the last term positive. If the middle term cancels, it means one has to be a plus and one has to be a minus, which means when we multiply those last two terms together, it's always going to be a negative.
Why not just make it a positive?
Then you
6?
have 3 terms because you're going to have a trinomial, right? If you did 5x plus 6 and 5x plus 6, I'd get 25x squared plus 30x plus 30x plus 36. And now I have a middle term. It's just not possible, okay? It's not possible to have two terms with a plus between them become the difference of two squares.
So
So this, you would literally write prime.
So if the 60x was there,
Then it's called the, and then it's factor, good segue, because
oh god.
that's the next time. We'll get there in a minute. All right, keep going here. Now here's where it's weird. Is an x to the 8th a perfect square?
Yeah.
It is, right? And that's weird because 8's not a perfect square, but it's even. So what's the square root of x to the 8th? X to the 4th. So with an exponent, you're when you square root, you divide by 4, right? Or divide by 2. What's the square root of 1? 1. 1 gets a plus and 1 gets a minus. Are we done? No.
Factor out
X to the 4th minus 1 is what? Difference of two squares again. First one's going to stay the same. Second one becomes x squared plus 1, x squared minus 1. So this was still the difference of two squares. Am I done?
No.
Because why?
Because then they're just the x.
This one is still the difference of two squares. So x to the 4th plus 1 stays. X to the 2nd plus 1 stays. But x squared minus 1 becomes x plus 1 and x minus 1.
So when you're factoring and there's still a negative, you can keep going.
If they're both perfect squares. So if there's two terms and they're both perfect squares.
Wait, so why are we doing this?
you're factoring. It's like it's a whole thing in algebra.
Like,
Mhm.
why undo the progress?
It's just a different method. You're just never gonna win the y on the factoring. It's important because we use it. You're gonna use it a bunch this year, actually.
They're gonna tell me to take this apart.
And then we eventually will solve these. So that's how you find answers to polynomials. Yeah.
It's like building
Yeah.
a Lego, and
Was
then
the
you
answer
kick it
to
down.
reduce on x plus 1, x minus
Just to
1?
rebuild something else.
So say that again.
Was the answer x plus 1, x minus
It's this whole thing. Because you'd keep all the ones that didn't factor, but you just keep factoring that second one and then that third one.
That's like buying a Lego
Hmm?
set for like a rocket ship and building
Sorry.
a car.
Thank you for sharing though.
Since it's
Yeah,
4,
it's like those Lego sets.
Isn't it 25 times 25?
So 625, factors of 625, square root of 625 is, and if you don't know it, 625 underneath the square root, 5 goes in there, 1, 0. Did I do that right? Nope.
No.
Just kidding. 125, which is 5, and 25, which is 5 and 5. So I could bring out one set of 5s and another set of 5s, which means the square root of 625 is 25. What's the square root of x to the 4th? X squared, and the square root of 1? 1 gets a plus and 1 gets a minus. Are you done? No. First one stays because it's a plus. Second one becomes?
5x.
Good. 5x plus 1 and 5x minus 1. And now we're done.
It's a question.
Yeah.
What if it was 625x to the 4th minus 2?
You couldn't do it. It would be prime.
Okay.
Yep. Maya, do you have a question? Okay.
What about minus 4?
Now you can factor, no, you can't factor out a 4. Oh, yeah. So it would be 25x squared plus 2, 25x squared minus 2. And then you're done. Right.
That's it?
Yeah.
Okay.
All right, go to 11. What do we do?
Can we just factor it by 3?
You can take a 3 out. What's 3 divided by 3? 1. What's 12 divided by 3? 4. So minus 4x squared. Am I done? No, 1 and 4x squared are both perfect squares. So 3, 1 plus 2x and 1 minus 2x. Okay, go to 12. Is that the difference two squares? Is this a perfect square? Yep. Is this a perfect square? Minus between? Yeah. So it's not numeric, but it is still the difference of two squares. So when I square root x plus 2 squared, what do I get? X plus 2. And when I square root y squared, y, 1 gets a plus and 1 gets a minus. Can't combine terms, so that's how my answer stays.
What if we got a question? What if it was like 4 to the power of 4 minus 1? How would you do that? Because then,
Like 4x to the power of 4?
because if we were to divide, just because 4 is a perfect square, but you can't go into it 4 times.
Yeah. So it would be 2x squared and 2x squared, and then plus 1 and minus 1. Is that what you mean?
Yeah, but
Yeah.
that would be the answer.
Mm-hmm. Because this is not a perfect square. It's the difference. Part of it's perfect square, but 2 is not a perfect square. So it stops there.
You wouldn't cancel out 1?
Nope. What do you mean cancel out?
Because there's 2 of the same.
2 separate.
Yeah, can't you do it again?
No, because 2 is not a perfect square.
What is
16 would break down into 4 and 4. That could go again. But 4 breaks down to 2 and 2, and 2 is not a perfect square.
I forgot to do his prime.
Yeah. Okay, we're going to come back to this. I think we're going to save these for tomorrow. Or if the end, we'll come back to it.
I'm gonna say maybe 3 if you minus 3.
All right, last one we're going to cover, which is the last thing that will be on your test, is called perfect square trinomials. What's the word trinomial mean? 3. So it has to have 3 terms. The first term and the last term have to be perfect squares. So So there's two parts to these, okay? The first is the test, and it's a little bit less obvious than the last one. Like the test on difference of two squares is that they're both perfect squares and there's a minus between. So they're both visual things that are easy to spot. The perfect square trinomial test is that they both first and last have to be perfect squares, and there has to be 3 terms. That's the first part of it. And then to test to see if it's a perfect square trinomial, you square root the first term, you square root the last term, you double the product. So it'd be 5x times 2. Without the sign, ignoring the sign, if that matches the term in the middle, then this is a perfect square trinomial. So that's just the test. Square root the first term, square root the last term, double the product. So it's the reverse of what we do with the special products, okay? If that matches the term in the middle, then you know it is a perfect square. So this is a perfect square. And the easy part is to factor it. You square root the first term, you square root the last term, you take the sign from the middle, keep it in parentheses, and square it. That's the answer. If I expand, that's a perfect, think about what we did yesterday, right? That's a special product. If we multiply that out, we would square the first term, we would square the last term, we would double the product. And now I get my question.
Where'd you get the 2 from?
You
Yeah,
always double the product.
Now, what if the
That's
one
not
in the
very
middle was a
nice.
perfect square? And then, let's say it was,
It actually, I don't think that can happen. But if it did, as long as it's double, no, because it's always going to be even because it's double the product.
but what if it was like x to the power 2 minus 25x plus 625?
It won't. So that would be 25 times x, but then you have to double it. So the middle term would have to be 50.
Question.
That would be prime. Yeah,
Why is it minus 5?
because you take the sign from the middle term.
Okay.
Yeah.
Okay, wait, so you square root.
Square root first term, square root last term, take the sign from the middle term, put it in the parentheses, square it. Yeah.
When you're like doing the square root of the first term square, the second term, and doubling the product, you see how it's like -10 and your answer is 10? Does that matter?
When we check it, it doesn't matter. When you factor it, it does.
So if that was a plus 10, it would be.
It would be x plus 5 squared.
Wait, what did you say?
He said when you're checking, when you're doing the test to see if it is a perfect square trinomial, and you do the square root and the square root, and then you double it, does it have to match the middle sign? The answer is no for the test. But when you go to actually factor it, the sign in the middle becomes the sign in the middle. That's where it comes back into play. All right, we're going to do a bunch of these. So again, remember they're all going to get shuffled together. It's not going to say like factor the perfect square trinomial. It's just going to say factor. You'd have to look at this. You'd have to first of all know that there's 3. So you're going to rule out the difference of 2 squares. I'm going to notice that the first term and the last term are perfect squares. So then I'm going to do the test. Square root of 16, 4x. Square root of 9, is 3. And then double that product. So that would be 12x. Multiply by 2, and I get 24x. Does that match your middle term? Yep.
So,
So that's the test. It worked. So now I factor it. Square root.
multiply the 2 terms that you get
And then double it.
Okay.
Yep. Square root first term, square root last term, take the sign from the middle, put it in the parentheses, and square it. $17. Are 9 and 25 perfect squares? Yes, this would be 3x times 5, which is 15x, times 2, 30x. Does it match? Yes, so then I square root first term, square root last term, sign from the middle, put it in parentheses, and square it.
Question.
Yeah.
What happens if the number, the last number, like let's say 25 was 14? What would happen?
So technically, it's not a perfect square trinomial then. There is another thing it could be, but we're not there yet.
Is that going to be next lesson or this lesson?
No, that's next lesson.
Oh.
After your test. Joey.
So even though that's a positive 30x and that's a minus 30x.
When we do the test, we ignore the sign. Yep. You're just looking for the value. Madison, did that answer your question?
Yeah, so we would just put prime, right?
If it was not a perfect
Yeah.
square. Yep.
Okay.
And then
Valerie.
you would do like 3x minus 5x, but why would you square it after?
Because that's just it. So that shortcut is the shortcut to factoring a perfect square trinomial. You always need two of them. So if I just left it as 3x minus 5, there's no way to get it back here. But 3x minus 5 times 3x minus 5 gets me back to there.
Oh, alright.
All right, 18. Perfect square in the first one, perfect square at the end. What's the square root of 4x squared?
2x.
2x. Square root of positive 1? 1. I get 2x. Double it. I get? Oh, sorry. Double it. You get 4x. Matches, so I know it is a perfect square trinomial. Square root first, square root last, sign from the middle, put it in parentheses, and square it. Still good?
It's gonna be 7 by 6.
God bless you.
Yeah, that makes sense. Yeah.
All right, 19. First one's perfect square. What's the square root of 36y squared? 6y. Square root of 49? 7. That product would be 42y times 2, 84y. So it checks out. Square root first term, we already did it. Square root last term, put a plus between, put it in the parentheses and square it.
But with the next one, since there's another
Yeah, the
variable,
next one,
wouldn't
no.
work.
So is the variable at the end still a perfect square? Yes. So at least that part's right. Now this would be 3u times 4v,
That'd be UV.
which is 12uv. Does that match the middle term? No, this would be prime. If it did say both, just so that you can see what it would look like.
And then because there's not one number that goes into all of them.
Right. So that would be the other thing you could check. Like 3 goes into 9 and 24, but it doesn't go into 16.
So you have to check that before it can
Yep.
use a complete
Yep.
Wait, what?
So wait, let me finish this one out. So if it did have both in the middle, so this would be 3u times 4v, 12uv times 2 would give me 24uv, and that works. So then I square root the first term, which is 3u. I square root the last term, 4v. I take the sign from the middle and I put it in the parentheses and square it. So if there is a variable on the front and the back, as long as they're both raised to an even power, they're still perfect squares. You just square root them. Yeah.
I was gonna say, so if it, since it's not like 24u, or uv, sorry, wouldn't that just make the equation wrong?
No, it's just prime. It's not that it's wrong.
How do you get 20?
20.
Like, how do you get 9u squared? Like, if it's not a perfect square trinomial, how do you get it? It's like,
We're not going to do that today. Don't. Because you don't need it yet. Don't put that in your brain to cloud it, to confuse you. Don't. You don't need it yet. I promise you next week we will learn that. But you don't need it yet, so you don't need to stress yourself out for it. Okay? That one actually would never factor. There is times when it does factor another way. That one would not. But there are times when it does factor another way. But we'll get to that next week. Okay, questions? I'm going to publish 2 things tonight. One that you have to do is the P.4a homework. It's on WebAssign and on Canvas again, okay? So that one you have to do. The other one that if you have the extra time, because a lot of this is fast, if you have the extra time and you want to start your test review so you can already come in tomorrow with some questions, I'm also going to publish, it's P2 to P.4a test review. It is non-graded. You do not need to turn it in to me, okay? It's like 20 questions because it goes through all those sections. If you want to start it today, start it today. Maybe save the factoring, the P4A, because you're going to have that for homework. Like you're going to do the P4A here. Maybe don't do those tonight. Maybe do those tomorrow, okay? But if you want to start them, it's a good thing to look through them. And if it's like, oh, I really know how to do that well, I'm not stressed out about it, and you need to focus on other things, do it. Remember, this is like where you get to really pay attention to where you need the help and focus on it. Yeah.